Hello, anatomy friends. This is Dr. Alsup, and in this video, we are going to be discussing the types of contraction as well as functional groups of muscles. We have 3 learning objectives to work through together. Make sure you feel comfortable with these and can answer these in your own words after we've had our discussions. All right, so let's talk through this term contraction. We have probably heard this our whole lives. It's a bit more complicated than just shortening of a muscle, although when we are discussing the actions of individual muscles in upcoming videos, I am talking about their actions when the muscle is shortening, aka concentric contraction. It's really important to note that contraction can also mean the muscle is producing internal tension, while an external resistance causes it to stay the same length, or it can even become longer. So again, it's just much more complicated than just that general shortening that we think about. There are 2 major muscle contraction categories. The first is going to be isometric contraction, which in this type of contraction, the muscle will develop tension without changing length. So these are kind of key terms here. I often imagine this type of contraction, if you visualize, you're wanting to lift a heavy dumbbell. And when you first contract the muscles of your arm, you can feel the tension building in them, even though that dumbbell isn't moving yet. Although it's important to note that isometric contraction is not just a prelude to movement, it can be utilized in joint stability at rest as well. So there is no external movement when we're talking about isometric contraction, but energy is still expended because you are still contracting at a molecular level. So you still need ATP and all of that good stuff. The other major category is going to be isotonic contraction. And with this type of contraction, the muscle will change length while maintaining a constant tension. So these types of contraction begin with internal tension building to a point where it can overcome resistance. So there is going to be external movement. And there are 2 types of isotonic contraction. There will be concentric contraction. This is the one we keep talking about. This is where the muscle will shorten. And then we have eccentric contractions. And here the muscles will lengthen. And these types of contractions are more prone to injuries because the sarcomeres and the connective tissues of the muscle are pulling in one direction while the weight is pulling the muscle in an opposite direction. So this is a leading hypothesis as to why these types of injuries often lead to more injuries. There are other types of contractions, and while obviously very important to muscle, they're often discussed in neuroanatomy portions of the course, as in particular a reflex arc. It's a very neurological process. So these contractions, they're not voluntarily controlled, but they will produce movement, often kind of a jerky type of movement, such as what happens in the patellar reflex. So when a physician hits the patellar ligament, it causes a jerky extension of the leg due to a lot of these neurological processes. Tonic contraction is happening all of the time. It's happening right now as I speak because muscles are almost always slightly contracted. This helps to maintain posture, joint stability, and muscle tone. So unlike the other types of contraction that we've been discussing, where these are typically kind of quick movements, tonic contractions are generally sustained, but not very powerful. It is extremely rare for a muscle to work in a vacuum. So they do not act independently. They will function generally as a group whose combined actions produce a more coordinated movement. And there are 4 categories of muscle actions. There's the prime mover, synergists, antagonists, and last but not least, we have the fixators. And one muscle isn't always the prime mover or always the synergist. It can switch around depending on the joint actions. So the action of the muscle very much depends on what the other muscles are doing. The prime mover is the simplest to conceptualize. It is the muscle that produces the most force during a particular action. So in this illustration on the right, we are seeing someone who is on a quest to take a drink of water or milk or whatever it is in that cup. And so they need to flex their elbow. This image is showing that the biceps brachii is the prime mover here. Although I take issue with this, the brachialis muscle that is deep to the biceps brachii is generally the prime mover for flexion of the elbow, but usually it's easier to conceptualize and see biceps brachii, so it often gets the credit because, again, it's easier to see. So in this particular case, biceps brachii is the prime mover. Synergists are muscles that aid the prime mover. This can be as simple as aiding the prime mover to help to make the action stronger. So that can be a redundant action. So it's doing the same action, just not as forcefully as the prime mover. However, a synergist action can also stabilize a joint and restrict unwanted movements, and even modify the directionality of a movement to allow the action of the prime mover to be more coordinated or specific. So it's a lot more complicated than just aiding. But in this particular image, so that quest for the drink of water, the brachioradialis, which can also flex the elbow, it's a weak flexor of the elbow generally, is the synergist in this case. The antagonist in this functional group opposes the prime mover. So this may mean it can completely relax or almost completely relax to give control to the prime mover. This is pretty rare, actually. Generally, the antagonist maintains some form of tension to limit the range and the speed of the prime mover. It often acts as a brake, so the other action isn't too powerful. The antagonist in this illustration is going to be that really large triceps brachii on the back of the arm. So that's going to be the antagonist to the biceps brachii. And then lastly, we have the fixators, which fix bones. So what does that mean? What does fix in quotation marks mean? Well, it means that it holds it steady. So when you don't want that bone to move, so this allows a muscle that has multiple attachment points to pull on something else if one of the bones isn't capable of moving. So the biceps brachii is an excellent example of this. It's a muscle with an attachment way up on the scapula, as well as having attachments further down in terms of the radius. So if you only want to be focusing, that biceps brachii really only wants to focus on moving the elbow joint, we want to stop the scapula or the humerus up here from moving. So you could have another muscle that has attachments up in this region, like the subscapularis, to kind of fix those more proximal bones to allow for that more forceful movement in the elbow. All right, excellent. We have reached the practice question, so let's think through this one together. When a muscle stretches or lengthens, what type of contraction is this? Is it concentric, eccentric, isometric, or tonic? All right, so let's look through these answer choices. Tonic, we know that is not going to be the correct answer there. That is going to be like muscle tone. We're talking about something that's a bit more extreme with muscle lengthening. Isometric, we do not have movement of the external movement of the muscle. So we don't have shortening or lengthening with isometric, so that's not correct. And then key in terms of the word here, lengthens. Well, one of these lengthens and one of these shortens. So you just have to know the difference between the two. Concentric contraction is going to be the shortening mechanism. So that, again, is the type of contraction that we often think about as concentric, but that wouldn't be the stretching or lengthening. That would be B, eccentric being the correct answer here. All right, excellent. Thank you so much for your time and attention.